Hello guys, this section is on Proteus plus Arduino. In this section today, we are going to see how to add Arduino library to Proteus and how to use Arduino IDE along with the Proteus. So let's head on to Proteus and click schematic capture. In most cases, Arduino library will not be present by default in the Proteus. So let's check whether Arduino is present or not. So go to pick a library and type Arduino. And you can see here there are some names related to Arduino, but they are not Arduino boards that we usually see. So that means that there is no Arduino board that present inside the Proteus by default. So we have to add Arduino board to Proteus by manually. So for this purpose, we have to download the Arduino library file from the internet. So I have already downloaded the Arduino library for Proteus from the internet, and the link will be provided in the description. You can download from there. So just tap Arduino library, and inside this you can see there are two files and one instruction test too. Open instruction. So this is the instruction about how to add library in the Proteus. Either you can follow this or follow my tutorial. So for adding of the library to our Proteus, we need to copy these two files. Just Ctrl+C, then go to this PC, then click OS. In most of your systems, many of the files, many of the hidden files cannot be able to see. Means they are all hidden. So we have to make them viewable. So for that, go to Views, tick the hidden items over here. Tick the hidden items. So all the hidden files become visible. From there, click the program's data and search for Lab Center Electronics. So we can see Lab Center Electronics over here. Just click that. Open Proteus 8 Professional. Then here, click on Library and paste the file that we copied. Ctrl+V. So we can see the two files that we copied from the zip file got pasted. So this way we have added the Arduino library to the Proteus. Then go to Proteus, then restart the Proteus again. Let's check whether Arduino library is added or not. For this, go to schematic capture again. Go to pick a library, search for Arduino. And you can see the name like Arduino 2. So that means those all are Arduino boards, but of different varieties. Arduino LilyPad is a circular Arduino board. Arduino Mega, it's a bigger one. Nano is a smaller one. This is a normal one that is mainly used for any purpose. Then some similar Arduino boards also. So I will use the common Arduino board that everyone uses. So click OK. So let's see how it looks. So I have already selected the board. Just tap here. So the board will come and again tap. So it will be permanently fixed. Just zoom in. I'm zooming in to view the board. You can adjust the view here by pressing over here and moving generally. Okay. Then tapping there, it will be fixed. You have to tap, otherwise it won't be fixed. You can see it is similar to that of an Arduino board what you see in real. So it have pins from 0 to 13 and pin number 3, 5, 6, 9, 10, 11 are PWM pins. That means you can able to control the voltage that being provided from these pins. And it have analog pins on the left. These are 5 analog pins, 6 analog pins. then ground is provided. This is a place where 5 volt means you can take the 5 volt voltage from here and give to any other source. This is the reset button. This reset pin that also provided, and this is a USB port for uploading code. This is the USB for uploading code. This is for power jack, this is for powering up the Arduino. So what you can see that it is same to that of a real Arduino what you see in real. So this is the advantage of a Proteus that so you can see most of the components similar to what you see in real. Now we have the Arduino board with us. Next we are going to see a small example of bringing an LED with the help of an Arduino board that is provided in the Proteus along with the Arduino IDE, which is a place where you will code the code for the Arduino. So for completing this circuit for LED blinking, you have to take LED from the library. So from pick a library, type LED. So I am picking LED blue. You can see the schematic diagram over here. Then click OK. I have selected every components. Then now you have picked the LED blue. Just tap here and put it anywhere you like. Connect any pin of Arduino with the LED to the one end. So just double tap, the wire will come. Again tap here. Then other end of the LED should be connected with the ground. So for getting the ground, go to terminal mode, ground, check the orientation. So this orientation is perfect for me. Then tap here and again tap here. So now the connections are complete. Now we have to write the code for blinking of an LED, which will be done in Arduino IDE. So open Arduino IDE in your software, in your laptop. Now open the Arduino IDE, go to files, go to new. So it will open a new tab for you. By default, Arduino has two syntax within them, that is void setup as well as void loop. The void setup is for running the code only once, and void loop is for something that should run repeatedly, like that of a loop. So you all know that how to blink an LED in an Arduino. So for that, you have to first mention the pin, this declaration of which pin that we are going to use. So I'm naming my pin as IN or IN1 equal to, and you can see the pin that I connected with the LED is 11. So I have to mention 11. So int IN1 equal to 11 semicolon. Inside the void setup, you are going to mention the pin mode. Make sure the M is capital. Then put your name of the pin. Then it is output, because we are providing output from the Arduino. So that is only part inside the setup. And go to void loop. Now we are going to write the code for blinking of the LED. Initially we have to provide high, some delay, then low, then delay, like that, and that will be executed continuously when the program runs. So in order to provide high, you have to use digital write. Make sure that the W is capital. Mention the pin and provide high. So high means provide high voltage, low means 0. It's like 1 and 0. 1 is for high, low is for 0. In Arduino, high means 5 volt and say low means 0 volt. Then delay for 4000 milliseconds. Then again low, so digital write. Sorry, IN1 low. And again delay 4000 milliseconds. So delaying means it actually waits for 1000 milliseconds and then take the command low command, then again wait for 1000, Then again take the high command. Since it is a loop, it will continuously execute. So this is the function overall. Before verifying your code, you have to ensure that you have ticked the compilation box inside file preference tab. So go to file, go to preference, you can see that compilation, that the box is unticked. So tick that box, because by only ticking this box, it will generate an hex file. So hex file means it's a file path that should be pasted inside the Proteus for running the code, for simulating the Arduino. So tick the compilation, click OK. Now verify your code. So save the code. Okay, it's got start verifying. Extend this and search for .ino.hex file. So if you find .ino.hex file, so copy except the double inverted commas, $C, and go to Proteus, double tap the Arduino. You can see a place where program files are there. So paste whatever you copied here, Ctrl+V, and okay. Now you have the location of the code which you verified inside the Arduino IDE, which is pasted inside the Proteus. Now click on play button for running the simulation. And you have noticed that the LED is blinking blue and turning off on off, like how it blinks. So thus we completed our small example. So today you have learned, or in this section you have learned about how to add a library, Arduino library, and you can add any other libraries that are not available inside the Proteus, like the same manner what I shown. And you have seen how to how say code written in Arduino IDE can be used inside the Proteus, that is by just copying the hex file, all these things. So thank you guys.